So I'm going to show you how the Imagine has added the capability of uploading spatial models authored in Imagine to the Smart M.App platform, where they then can be used in a Smart M.App and run and produce the results just the same as if you had run it in the Imagine environment. In order to do this, you have to have two things. First, you have to have your login credentials for the Smart M.App platform. And secondly, you need an app assigned to you called Imagine Connect. And for both of these things, you would have to get these from Paul Kennedy or Sherry Gilbreth. They're the people that assign access to the different apps, and they're the ones that will give you the Imagine Connect app. Once you've done that, then when you go to Imagine, you have this option here, log into Smart M.App. And I'm going to show how we can make our model, and we'll log in just a second. First, I'll kind of describe the model and what it does. This is a change detection model. Here's a couple images from different dates. Obviously, there's changes you can see visually. And so the model is one that basically took some of the underlying algorithms that's in the zonal change processing, part of Imagine's zonal change product, and made it into a spatial model that would just have two rasters in. It would compute the probability of change at the floating point 0 to 1, then scale it to 8-bit, and then apply a color scheme. And this is similar to the indices smart maps that our team's been working on. I'll show you one of those at the end of this presentation. But that's what this model does. And the result actually looks like this. So you have a kind of blue to red, cool to hot color scheme. It's called the Imagine Spectrum. And you know, it does a good job of finding. Of course, there's a big change up here, and there's a change down here. It looks like this is some kind of mining operation, and they got less water and more land right there. They've been dumping things, and anyway, so that's what we can do in Imagine. This is all run in Imagine. But say we want to take this model here, and we want to put it in a Smart M.App. You go to the log into Smart M.App. Click on it. Takes a couple seconds to log you in. And now it says Brian Clore at Hexagon Geospatial. So I'm logged in now, and I can go to the Spatial Modeler menu, upload to Smart M.App. You have different uploads for your models now, and we want to upload this to Smart M.App. Call it change detection demo. I already typed that in. You can put in icons, and you can put in a more detailed description of what the model does. And that's all there is to it. You log in, and you go to the spatial model, and you say public or upload to Smart M.App. And so we're done really on the Imagine side. We'll look up on the Smart M.App side now. So I don't know if you're familiar with Map Studio, but Map Studio is the application that allows the user to build a Smart M.App without having to know JavaScript or programming or anything like that. And you can put recipes in, which is what spatial models turn into recipes in Smart Maps, and then build apps that run those models specifically. So right now we're looking at all my maps. Let's go over to recipes, and we should see the one that we uploaded, change detection demo, right here. And you can edit it. Let's take a look at it. So it has a graphical editor very similar to Imagine. You have the layout and the connections, the operators, the ports, and so forth. You have all the properties of the different operators over here, data types and so forth. So the information content is all pretty much the same. The interaction is very similar, and it's easy to use. Here are all your operators over here that you can add into the editor. So you have two authoring tools. You can do it as Imagine, bring it in, or you can build your own recipe using the tools in Studio. So we have this now, change detection demo. I need to save it. It was just uploaded, so it hasn't been saved yet.
And this is all transactions that are occurring on the server, Brian.
Yeah.
You sent a request back, and
Yeah.
the server to respond and say it's done.
Right. Okay. Came back and said it's successful, and it should show up in our list here. I had another one I've been playing with, but it hasn't been published yet. This is my list of published ones. So we need to publish it. There's a publish icon right here. So now I'm publishing the recipe. So now it's good to be used in a Smart Map. You've done what you needed. You've brought it in from Imagine, saved it, and published it. So now we'll go back to the Map Studio, and we're going to say create a new map. And this is the panel in which we're going to build the map. We have toolboxes over here and templates and so forth. We're going to just make a simple one that has a side-by-side set of two panels. And you can put different things in these panels. You have these choices of maps, by maps, workflows, recipes, and custom. And we're going to put the recipe that we just created in this particular panel. And it's going to show me the available published recipes, and here's the one that we just saved and published from Imagine. I forgot, you could come here and it does something similar to what Imagine does. It builds a UI interface for you so that you can enter your data here. There's also, when you run it, it'll also prompt you again when you run it. So I'm putting my two images in as the before and after image, and the name of the color ramp we use is called Imagine Spectrum, and then you can give it an output name. So for over here, we're going to put a map and a by map. By map allows you to add multiple things, multiple layers, and so forth. And I've already uploaded my imagery, and I've already created this map. So it's called image change images. Now we're going to do something that allows these two different panels to communicate with each other through the publishing of to the catalog and then sending it to the map on the right.
I want to show the resizing of the panels.
Oh, sure. Yeah.
A little narrower.
Yeah.
So you just drag that center line to make the panels bigger or smaller.
So we go to the Customize tab or button here in the process, and you can put in JavaScript, cascading style sheets, and external, what's EXT?
External is getting external Java
External Java service or
like Google API,
yeah,
or something like that.
And we put in code samples for how to do simple JavaScript things without having to actually write the script ourselves. So we'll do the JavaScript here first. And what we want to tell it to do is after it runs the spatial model to publish it to the catalog. So we come down here to catalog operations, publish catalog item, and send to map. You just drag that into the custom script, and there's the JavaScript that's going to do that for you. So we can close that one, and then for the map itself, there's also some script that does that, and that is add catalog item to map. So we drag that in for this one. And now we're done making our smart map. We've chosen the recipe, we've chosen our base map layers that we want the results to go on top of. And all we have to do now is name it. Oops. And save it. Okay, successful. We'll go back to the main studio page, and now we'll look at My Maps, and it should have the new one we just created. Here it is, change detection demo, and we can run it from here. We could also go back and edit it if we chose to. There's my inputs for the model ports, and I entered them earlier, so it held on to them. If I hadn't, these would be have to be populated again, but since we have them, we're good. Here's my 2 images that I showed in Imagine, same 2.
Those images are actually part of the map.
Right.
The MAP as opposed to the M.app.
Right, right. Lots of maps, but yeah, you have to make the map and upload the content and the steps that really weren't relevant to what we're trying to show, but are in the Map Studio training videos and documentation. So we're just going to go ahead and execute it, and it's going to take a couple minutes. So while that's going on, we'll come back and look at the results. We're going to go look at another set of maps. Well, let me go here. No, not there. Let me go here. So our team has been developing our own apps. You've probably heard of the vegetation index-based maps, and the incident analyzer has been shown a lot and talked about. We developed that, and then we have, I think, 10 indice apps. These are all just apps that run spatial models and produce a result similar to the change detection one we just looked at. But we have a prettier front end. We have developed our own custom script, Java code, to build a better web interface for these particular ones. I'm going to show you the one in a minute. But we have things for different kinds of vegetation, snow, water, burn, and iron oxide. These are all done, and we're just awaiting publication.
So there's like, what, 5 or 6 vegetation ones, a couple of hydrology ones with snow and the water, and there's the burn and the iron oxide. So yeah, there's different categories of indices. We just selected 10 of the ones that Imagine had and made smart maps out of them.
Yeah, and they all pretty much look and feel the same. You put an input image in up here. You can drag from your desktop or browse for an input image and hit upload. It automatically uploads it to Map Chest and displays it in the viewer. I'm just not showing you every step, but this is how essentially it works. There's a few user parameters. One is you have to tell it what sensor it is, because it's doing an index and it needs to know which bands map to which wavelengths, and that's in the sensor information that we have stored. This is a NAPE image. And then the color scheme you want, we have several pre-canned ones. There's one really specifically for vegetation, and there's just these kind of spectrum ramps. Of course, there's a grayscale that might be useful and a couple other ones. So I think we picked spectrum for the one we've been working on. The output format, you can do GeoTIFF, JPEG 2000, or Imagine. And then the output name's auto-populated with the name of the input, the name of the color scheme, and the name of this particular index, which is NDVI.
So Brian, this model that is using the new operator that we developed called apply index, or?
It is.
Yes, yep.
So, as you don't have the model here to show, right? Do you happen on the model that he's using behind?
I can get to it if you wanted to see it.
No, I just wanted
Maybe
to show
after
that
that.
people that context that in the context of our Imagine, this apply index is a new operator that allows you to do any indices that Imagine supports in Spatial Modeler with just one operator.
Right, yeah. And the sensor name goes right into the port for the sensor name of that operator. So we're using for all of these. It turned out to be exactly what we needed. Was like you had to add one, but we didn't have to change any of the way the behavior of the operator was.
Right. And yeah, so the model is very similar between the various indices. We just do a little different scaling after you get the floating point value from the index. We scale it to 8-bit. We do that differently for each index to try to make the colors look nice on the output.
So here's the output of the vegetation health index, and that's the input and that's the output. And so basically there's 10 of these. We tested them on lots of different types of data sets. We have some that work well on WorldView 2. We have this one on NAPE, and you have to have the bands appropriate for the index, of course, and it does check for that. So we try to make it real easy to use, a real simple Smart M.App application to kind of get our feet wet, right? So we wanted to get some stuff out there, and we knew, Larry and I know Spatial Modeler, indices and stuff like that, so we did all the back-end work, and then Dave and Joel on the team did most of the actual web-based development. We can go back and see if the one loaded. Let's see, where was it? Oh, okay, there it is. So it says model executed successfully. This is ran the spatial model authored from Imagine and ran it here, and we have basically the same result.